This one we are still looking at measuring irregular areas, but in this case we are going to have a revision of Herons' formula. Now this is one of those bigger formulas here some people struggle to use, but it's about going slow and it's about just filling it in step by step. So when I'm looking at a diagram like this, I go, alright, I've got to break it up into a couple of areas and I've got to figure out what I'm doing. So I'm trying to find the area of this reserve which is shown here. Make sure that everything's in the same units. These are all in meters, which is good. If they're not in the same units, you need to make sure you convert them to the same unit. Now what I'm looking at is I have area 1, which is a trapezium, and area 2, which is a triangle. The problem with the triangle is there is no height on it. So that tells us that we are going to have to use Herons' formula. So what I'm going to start with first is area 1 because I wrote it. Now when we are looking at area 1, just put your title down. Wow, that's a different one. Sorry, I hit the wrong button. Try that again. That's the one I wanted. So we're looking at area 1. I just put a title. That's what I like to do. The formula for a trapezium we can put down. So area equals. Now a couple of different people have different formulas from here. The more traditional one is length 1 plus length 2 divided by 2, put it in brackets, times by height. Now, for those who are wondering what do I mean by length 1 and length 2, they are the parallel sides of the trapezium. That's length 1, that is length, you know, to write sideways, 2. Okay, so you'll notice that these are the parallel sides of the trapezium. That's what we call length 1 and 2. So it's 64 plus 92 divided by 2 times by the height, which is 28. And we put all of that into our formula. Sorry, we already put in the formula. We put all that into our calculator and we come out with 2,184 meters squared. So that gets area 1 out of the way. Area 2, we have to use Herons' formula. So, in Herons' formula, we're going to need sides A, B and C. So my advice to you, so you don't get things mixed up later, is go and label your sides. It doesn't actually matter which side you label which letter, as long as you keep it the same throughout the whole formula. So A, B, C. And I do that just so I don't mix up which one's which. So with Herons, we always start with, write down the formula. So area equals the square root of S outside of S take A, S take B, and S take C. So that's Herons' formula. Now the big thing is what is S? So S is half of, in brackets, A plus B plus C. So we can work out what S is. A is 45, B is 57, and C is 92. So we've worked out that S will be equal to 97 meters. Because we know S, we can sub into the formula. Be very careful when you're writing here because it's very easy to make mistakes. So, spread it out. Be as neat as possible. We'll see how we go. although it is possible to type this directly into your calculator, my advice is to simplify it a little bit before you do that. So what am I talking about? I would do this. In your calculator, what does 97 take 45? And you'll get 52. 97 take 57 is 40. And 97 take 92 is 5. So that's my advice. Simplify it. This makes things easier to put in your calculator. Bit of communication as well. And we get roughly 1,004.3 meters. So, we found the area of area 1 and area 2. So the total area will be area 1 plus area 2, which will be 2184 plus 1004.3. And we get 3188 meters squared. That's rounded a little bit there. Okay? So really I should put the 0.3 in. And that is the trapezium formula for area 1 and Herons formula for area 2. So just a little bit of revision on that one.